Assalamualaikum and a very good day to you all. In this video, I would like to show you on how to get the first derivative by using the first principle. So what is first principle? First principle is defined as f prime equals the limit, the limit of fx plus h minus fx over h as h approaching 0. Okay, so by using this this formula, first principle, we can get the first derivative. Okay, let's get started. So let fx be a constant function 4. Okay, so this constant function 4 can be visualized by having this graph. Okay, so this is x, this is y, and the line is 4. Maybe different color lah, green. Okay, so this is a constant function. Now if when it's x, then the y is 4. Okay, let's get fx plus h. Okay, now x plus h means we add some more h, and then this is x plus h. Okay, so let's see what is the y is. Since it's a constant function, we still have 4. So if we get these two already, we can apply the formula upstairs. Okay, so f prime equals limit h approaching 0. So what is fx plus h? It's 4. Okay, maybe use green color lah. Okay, and then minus fx. Where is fx? Fx is over here, 4, and then over h. Now, so limit h approaching 0. So 4 is 0 over h. Now 0 over h is 0. So limit h approaching 0 for 0 is 0. So that's how we get the first derivative of fx equals 4. So the first derivative is 0. I rub this off lah. Okay, so this is the first example. Okay, let's try different function. Fx maybe a linear. Okay, 2 minus 3x. Okay, so wait, I move it further. Okay, perfect. Now, so let's get the fx plus h. Okay, now, so for this one, it's quite trivial. Like in the function chapter previously, if we have fx, then it's 2 minus 3x. So what happens if x plus h? It's 2 minus 3x plus h. Okay, you can expand them if you want to. Okay, 3h lah. Okay, so we got already these two. We can apply first principle. So f prime is the limit hx approaching 0. So f x plus h is this one, right? So 2 minus 3x minus 3h. Okay, and then fx is this one, sorry. Okay, so minus 2 minus 3x. Okay, now limit h approaching 0, 2 minus 3x minus 3h minus 2 plus 3x over h. Now for this one, minus 3x plus 3x becomes 0. 2 minus 2 becomes 0. So what's left is minus 3h over h. Now we can cancel the h, leave us with limit h approaching 0 minus 3. Therefore, the first derivative is minus 3. Okay, so that's the first derivative for linear function. Okay, let's proceed. Maybe we try quadratic, yeah. So fx equals x squared plus 3 maybe. Okay, so let's get the fx plus h. Okay, so this one, remember, it's like function. Okay, if we adjust the object, then we treat the object as the whole bracket, and then we change it whatever we want it to be. Okay, so as you can see there, I changed the x. If it's x over there or x over here, and if it's x plus h over there, it must be h plus x plus h over here also. Okay, so let's apply the f prime. Limit h approaching 0 when fx plus h is x plus h squared plus 3. Okay, and then minus what color? Red lah. Okay, this one fx. What fx? X squared plus 3. Remember the bracket, because there are two terms, two different terms, so we have to expand the negative later. Okay, now alah, too small lah. Okay, that's better. Okay, wait, why? Okay, limit h approaching 0. Okay, so this one we expand them, x squared plus 2 hx plus h squared plus 3 minus x squared minus 3 over h. Okay, now x squared minus x squared becomes 0, plus 3 minus 3 becomes 0. So what's left is 2hx plus h squared over h. And then we're taking the limit as h approaching 0. But before that, we can factorize the numerator. We can factorize h. So h outside, 2x plus h over h. Okay, and then we take the limit h approaching 0. Now the h we can cancel out or divide them accordingly, leave us with 2x plus h. So we substitute the h with 0, leave us with 2x. So this is the first derivative for fx when fx is x squared plus 3. Okay, let's try this one, that one. Okay, let's try fx equals 1 plus x squared. The one 2 minus 1 minus x squared. Feels challenge. Feels a little bit challenging. Now, wait, okay, I just turn off the notification for people doesn't come out. Okay, now let's get the fx plus h. Okay, what we have, 2 minus 1 minus x plus h squared. Okay, notice this one, this one, this one, this whole one. Okay, so be wary of the negative. Don't do it don't just substitute like that. Okay, so f prime is what? Limit h approaching 0 for fx plus h minus fx over h. Now, what is the fx plus h? This one whole lot. Okay, so we are going to ganti minus 1 minus x plus h squared. Okay, and then what is the fx? That one, make it thicker lah. 2 minus 1 minus x squared. Okay, so as you can see, we have to expand this and this. So the working will be a little bit long. Okay, so just bear with me. Or maybe I thought on pausing the video and then just right away do the expansion, but don't want lah, later confuse you all. Okay, so 2 minus, okay, this one bracket. For the first red bracket there, we have two items there. We have 1 and we have x plus h. So we expand them one by one. So 1 squared minus 2x plus h plus x plus h squared, and then close the bracket. Okay, and then the green one, 2 plus, okay, I expand the negative, and then I expand the last green bracket, and then 1 squared minus 2x plus x squared. Okay, and then over h lah, don't forget. Okay, and then okay, continue, h approaching 0. Okay, so 2. So this one we expand the negative inside here, do it properly, minus 1 plus 2x plus 2h. Okay, and then we are going to expand this one also. Okay, okay, so plus negative lah. Oh yeah, negative x squared plus 2h x plus h squared. Okay, minus 2 plus 1 minus 2x plus x squared. Okay, now from here we can get rid of something. For example, 2x here minus 2x here becomes 0. Minus 1 here plus 1 here becomes 0. 2 here and 2 there becomes 0. Okay, leave us with, oh, the h here, sorry. So leave us with no need too long lah, this long I guess. So it leave us with 2h minus, I expand lah, okay, right away, minus x minus 2hx minus h squared plus x squared over h. Okay, and then limit h approaching h approaching 0. Now, and then this one also we can get rid of some things. The first one is this one, minus x squared plus x squared becomes 0. Okay, leave us with 2h minus 2hx minus h squared over h, limit h approaching 0. Now for this one, we can get rid of the h. Okay, we can factorize them. Okay, we can factorize them. So this one will be, I'm going to write over here, and then I will rub the left part, and then we replace them. So h outside, 2 minus 2x minus h. Okay, so is it correct? Correct. Okay, and then I rub this off, and then I'm going to replace this over here. Okay, why I'm doing this? Because we can potong this to h, and then limit h approaching 0 for 2 minus 2x minus h. We replace the h with 0, therefore we get 2 minus 2x. So this is the first derivative for the quadratic function that we have just now. Okay, so if you think it's too fast for you, you can replay the video or pause this part to see the working, how it's done. Okay, this one, okay, it starts from there and then down there the f prime lah. Okay, so okay, I think maybe we can continue with another example. Okay, that one square already. Okay, set lah. We try fx when it's a cert, cert 3x. Okay, now let's find the fx plus h. Okay, fx plus h is 3x plus h. Don't want lah, lose the 3 lah, x only x only. Okay, x plus h. Okay, now so from here The f prime is limit as h approaching 0 for this one, okay, set x plus h minus this one, set x over h. Okay, now for this one, what should we do? You see a fraction, right? Over here, fraction, right? If we have a fraction and then we have to get the limit h approaching 0, we direct substitute what we get over here. We will get 0 over 0. So if we get 0 over 0, we should do conjugate or factorize. Okay, which one we should choose? Because there's a cert over there, we might use conjugate. Okay, so that is what we are going to do lah. Okay, so multiply by the conjugate. What is the conjugate for the cert part? The cert, in this case, the cert part doesn't necessarily be in the denominator. It can also be on the numerator, just like this example. So this one, you have two choices. So we negative the positive cert, or we positive the negative cert. No problem. There are two certs anyways. So I'm going to positive this one. So positive cert x. So this one just copy paste lah. Okay, perfect. Now the next step is to expand all these things. We expand the numerator. The denominator no need to expand. So just put them side by side like this. H plus cert x. Okay, just like this. Just make the denominator stay put like this. No need to expand some more, because we are going to cancel the h outside. Okay, so let's expand this thing, the denominator. Okay, so this one multiply this one, I get x plus h cert squared. Okay, and then the first term in the first bracket, the second term over here, so I get plus cert x plus h. Okay, and then the second term here, I multiply with the first term in the second bracket, minus cert x plus h. And last but not least, the second term and the second term in the second bracket, minus cert x squared. And then we take the limit as h approaching 0. So what we have is the first bracket is x plus h itself. This part will become 0. So leave us with x too long. Okay, and then I copy lah this part. Copy and then paste down here. Yay, easy. Faster also. Limit h approaching 0. Okay, and then you see this x and minus x can be minus, right? So Allah, copy. We can get rid of them. Okay, get rid of them. Lose. Okay, now this is what I meant. We see over here, we can cancel, right? So leave us with that. Okay, and then paste some more lah, easy. No need to write. Okay, now so this one lose. This one lose also. Leave one. So what to do? We substitute. This one was lose also. No need. No more. Okay, so 1 over cert x plus cert x. So we have 1, 2 cert x. So this is the first derivative for cert. Okay, so I think that's all. 20 minutes already. Maybe it's too long for you. Okay, thank you for your time and attention. Assalamualaikum. Have a good day.